Hello and welcome back to another video. So today I've got another full PC build guide for you, and I'm going to be showing you how to put all the parts I've got in front of me together today to come up with a fully working PC by the end of the video. So if you've not built a PC before, you've come to the right place. I'm going to be going through everything step by step. So let's have a look at the parts I've chosen for today's build. So starting off with the case, I've gone with Fractal Design's latest case. It's the Meshify 2. So this is not only a great looking case, but you can fit an awful lot of hardware into it. It supports motherboards up to EATX. It can support up to 9 140mm fans, 3 are included with the case, and there's lots of support for large radiators with a 360mm radiator supported at the front and up to a 420mm radiator supported at the top. We'll have no problems fitting large graphics cards as well, with graphics cards up to 491mm being supported. For the motherboard, I've gone with MSI's X570 Unify. This is an all black motherboard without any RGB, and I think it's going to fit well with the theme of the build that I've got planned. For the CPU, I've gone with the Ryzen 9 3900X, which is a 12-core CPU. It's going to be great for productivity, but will also work very well for gaming as well. So although the Zen 3 Ryzen CPUs have been released, they're not currently available to buy anywhere at the moment. They're fully sold out. So if you are one of the lucky few who's managed to get your hands on one of them, or if you're watching this video later on when they're widely available, the steps for building with them will be exactly the same as the 3900X. For RAM, I've got 64GB of Trident Z Neo in 3600 MHz speed. For storage, I'm going with all M.2 SSDs for this build, and I've got 2 drives from Samsung. I've got their latest 980 Pro, which is a Gen 4 drive, but I've also got their 970 Evo, which is a Gen 3 drive, both in 1TB of size. Powering the whole build, I've got an 850 watt fully modular power supply from Corsair. It's their RM850X. For the graphics card, I've gone with the ROG Strix 2080 Ti, and the reason I've gone for that is a very similar story to the CPU. I'm still waiting to get my hands on a RTX 3080, and I've had a pre-order in from day one, very slowly working up the queue to getting it. If you are one of the lucky ones who's managed to get your hands on one of the new 3000 series cards, the step for building will be exactly the same as with the 2080 Ti. And one of the nice things about this case is you're able to support very long graphics cards up to 491mm, so you shouldn't have any problem fitting any of the new graphics cards into this case. So I've already mentioned this case comes with 3 140mm case fans included. We're going to fill up 3 of the case fan slots with our 360mm AIO, leaving us 3 potential spaces we can add extra case fans to. I have picked up 3 extra case fans. They're 140mm fans from BQuat. They're Pure Wings 2 fans. I've used these in a number of builds before and been impressed both with the noise and the cooling performance. I'm not sure if I'm going to occupy all the 3 additional slots. I'm just going to see how the build goes today, but I've got 3 fans should I want to do that. Final part of the build, none of my builds would be complete without some cable extensions from Cable Mod, and I'm going to use some black and white cable extensions in this build. Okay, so that's all the parts. Let's get on with the build. Okay, so the first thing I like to do in any build is to prepare the case. And by preparing the case, I mean remove any panels, dust filters that are going to get in the way during the build. This case has quite a few neat features in it, so I'm going to spend a little bit longer and show you each of these features in this section as well. To remove the side tempered glass panel, there's a little notch on the back of the case, which we just need to pull forward, and then we can lift the panel straight out. It's exactly the same process on the back. There's a little notch at the back of the case which we're going to pull forward and lift the panel straight out. There's an additional cable cover down here at the back which we're going to pull out and lift out. The mesh bit of the front panel is on hinges, and to open it you just need to grab the Fractal logo and it should slide out to the side. It doesn't open all the way, but this panel can be removed by just pulling it forward. Now what you'll notice, this is actually 2 different layers. At the back we have an optional dust filter which can be removed just by pushing up here, and this slides out. So what Fractal Design are doing here is giving you a choice as to what is most important to you. If it's airflow and having the best possible temperatures, you can leave out this dust filter and just work off the mesh front panel without the dust filter. If you're more concerned about dust getting into your case and less concerned about temperatures, you can have both layers of mesh and dust filter at the front. I am going to be testing the effects of removing the dust filter and just working off the mesh, or having both of them in my full case review. So you might want to check that out before deciding whether you want to leave this out or not at the front of your build. To remove the rest of the front panel, you simply just pull it forward. There is an additional dust filter down the bottom of the case which you simply remove by just pulling it forward. To remove the top mesh panel, it's just a matter of lifting it up at the front and it simply lifts off. Similar to the front panel, there's also an optional dust filter on the top of the case. To remove it, all you do is slide it to the back and then it simply lifts off. And again, you've got the option of going just with a mesh at the top or mesh plus filter. Another really nice feature of this case is the top panel is fully removable. And the reason you may want to do this is if we remove this top panel, we can install our radiator on the top panel on the table, which is generally much easier than trying to do it in the case once the motherboard has been installed. So to remove the top panel, there's just two screws, one here and one here, that we need to remove, and then it will simply lift off. Down at the bottom of the case, there's a two-part bracket which can be removed, and the reason you may want to do this, if you're going to install additional fans down at the bottom of the case, which should help with GPU airflow, or if you're going to install a radiator at the front of the case. And the bracket's in two parts, so that if you're only installing the fan, you only need to remove the first bit of it. If you're installing a thicker radiator, you can remove the whole thing, so there's quite a lot of support here. To remove this bracket, all we need to do is push up from the bottom, and it simply slides out, and again it's in two parts, so we can go ahead and put just one part of it back if we need to. And probably this is what we're going to do, because I think I'm probably just going to put an extra fan down at the bottom. But for ease of building, I'm going to take the whole thing off for now. Installing the power supply in this case is made easy by removing a little bracket at the back of the case held on with two thumb screws. What you do is just loosen these thumb screws to remove the bracket. You fix this bracket to the back of your power supply, and then you can just install your power supply in at the back. And this is definitely much easier. In other cases where they don't have this bracket, you need to slide your power supply in from the back side, and it's a bit more difficult to do than sliding it directly in from the back. So another nice design feature. Down at the bottom of the case, we've got a hard drive cage. To remove the drive brackets, all you want to do is loosen the little thumb screws. This slides out. You can install your drive before putting it back in again. So although the hard drive cage is fixed in position at the moment, we have two options with it. We can loosen the screws at the bottom of the case, which are going to let us slide the hard drive cage to a position that we want along the bottom of the case. The other option is we can remove the hard drive cage altogether, and that's going to allow more space for cables at the bottom of the case, but also for two 140mm fans at the bottom of the case as intake, bringing more cooler to the GPU should we choose to do that. I'm not sure how well two 140mm fans are going to fit alongside the power supply, but we'll see later on in the build. So I'll show you first of all moving the hard drive cage from side to side, and then I'll show you as well how to fully remove it from the case. Okay, so we've got 4 screws here, and if we go ahead and loosen them, we're now able to slide the hard drive cage at the bottom of the case. So we can put it to a place we want it to be, and then obviously tighten the screws again to secure it in place. So as I've mentioned, I'm not going to install any hard drives or SSDs in this build, so I'm going to go ahead and remove the hard drive cage altogether. So to do that, I just need to fully remove these 4 screws holding it in place at the bottom of the case. And then with the screws removed, we can remove the hard drive cage through this cutout. So a few more things just to point out at the back of the case. We've got lots of little straps and channels, which are hopefully going to make cable management that bit easier. We've got a little fan hub at the top of the case, which I'll show you how that works when we come on to look at the case fans. And as well, we've got 2 additional brackets down here for 2.5-inch SSDs or hard drives. So another option you have with this case is to convert it from its current mode, which is open mode, into storage mode. And to do that, what you want to do is move this panel at the back to the front of the case. And that then allows you to install a whole lot of hard drive brackets to the back of this panel, really increasing the storage capacity of the case. As I've already mentioned, I'm not going to install any hard drives in this build. I'm going all with M.2 SSDs, but I will show you how to do this for completeness. So there's 5 screws we're going to need to remove, 3 at the front, 1 at the top, and there's also 1 at the back, which I'll show you in a minute. So we'll start off with the ones at the front. So now you should just be able to lift this panel out. Okay, so this is the bracket that we have removed from the case. On the back of it, you've got this little multi-bracket, which you can install an SSD or a pump reservoir mount. We're going to need to remove it because we're going to install our hard drive brackets onto the back of here. It's held on with 4 screws, so to get to them, we're going to need to remove this metal panel at the front. So just a matter of pushing it up and out. And then we can remove these 4 screws to get the multi-bracket off. Okay, so this is our little multi-bracket, and as I've said, you can install a pump and reservoir combination onto it, or you can also use it for an SSD mount. So we'll go ahead and get our bracket back into the case. Okay, so we just need to put this panel back in place. And then we're going to secure it on again with the same 5 screws that we removed earlier on. Obviously we can't screw the one at the top into anything at the moment, but whenever we put our top panel back on, there's a little hole at the top now that is going to let us screw into it here. Next thing to do is install the drive trays on the bracket at the back. 2 of these come in the hard drive cage, and there's additional 4 in the accessory box. You can obviously buy more from Fractal Design to fully fill this up, and you can install a total of 9 of them here in this bracket and a further 2 in the hard drive cage down below. So all we need to do is slide this in at the back, and then there's a little thumb screw here to secure the drive in place. And as we've already mentioned, you can of course keep the hard drive cage in below as well, with a further 2 drive trays in it. And then just a quick look at what that looks like from the front. Okay, so a really nice option you have with this case. Not something I'm going to use in today's build guide, so I'm going to go ahead and put this case back into open mode, and then we're going to go on to the next stage of the build, which is having a look at the motherboard. Okay, so this is our motherboard, and we want to do as much work with the motherboard as we can on the flat table, because installation is much easier on a flat table than it is in the cramped confines of a case. So we're going to go ahead and install our CPU into the socket in the middle of the motherboard, our M.2 SSDs into these sockets here, and our RAM into here before we put the motherboard into the case. So the first thing to do is to prepare the socket to receive the CPU. So to do that, all we need to do is lift this little lever here all the way over to the right hand side. So a really important feature of the socket is you'll notice this top left hand corner has a little triangle on the corner of the socket, and there's also a little white dot on the motherboard itself. So this little mark is going to be important because it's going to help us orientate our CPU in the socket in the correct orientation. Okay, so this is our CPU. What you'll notice is I'm holding it by the edges, and the reason for that is I don't want to damage these gold pins over on the bottom of the CPU. If I was to damage these, I could actually render our CPU absolutely useless. The other thing I want to point out to you, if you look at the corner at the top of the CPU, it has a little gold mark, and we're going to line this up with the mark I've already pointed out to you on the socket. And if we turn the CPU over, you'll notice there's a little gold triangle on the same corner. So we're going to line this up with the mark on the socket. Okay, so I've got our CPU here. You can see in the bottom we've got the little gold triangle, so I'm going to line that up with the mark on the socket. I'm just going to hover the CPU over the socket and let it fall into place. It's really important I don't push it down where I can damage those gold pins. So I'm just going to hover it around. And you hear how it's just fallen into the socket just there now. So all I'm going to have to do to secure the CPU in the socket is close this little lever. And we've now installed our CPU. So the next thing for us to do is to install our M.2 SSDs. And this motherboard has 3 sockets. We've got one here, and one here. And it's really important you look at your motherboard manual to find out the specification of each of the sockets, so you're installing your drives in the most appropriate socket. All 3 of the drives in this motherboard have 4 Gen 4 PCIe lanes associated to them. The one at the top goes straight to the CPU, while the bottom 2 go to the chipset. So the top one is going to be very slightly faster. Not that we'll notice it, but we're going to install our faster Gen 4 drive into here, and we're going to put our Gen 3 drive into the next one down. In other motherboards, there can be quite a significant difference between the sockets, so it is really important that you check this out. For example, most B550 motherboards only have one Gen 4 M.2 socket, and in general, the top one tends to be the fastest one, but it is worth checking your motherboard manual to make sure. So the first thing we're going to have to do is to remove the heat sinks from the 2 sockets we're going to install our M.2 drives in. So each of them is held on with 2 screws, so we'll get these removed. Okay, we should now just be able to lift the heat sinks off. Okay, so this is our M.2 SSD. You notice the little gold connectors over the right hand side, which are going to go into the socket. The little gold semicircle over to the left hand side of the drive is where we're going to secure it in place using a screw. So our top M.2 SSD socket is here. What you'll notice, we've got standoffs over to the left hand side of it, and this is where we're going to secure the drive with a screw. So we're just going to line our drive up with a socket, and what we can see is the standoff is in the right location. There's little extra holes here, so you can move the standoffs if you have a shorter drive. To install the drive, all we need to do is insert it at a slight angle into the socket and apply a little bit of pressure. We're then going to go ahead and secure the drive in place using one of the screws that comes in the motherboard box. So it's exactly the same process with the drive below, just insert it into the socket at a slight angle. The only difference with this one is whenever we screw our heatsink back on, the screw from the heatsink is actually going to go through here and secure this drive in place. Important to mention, if you are using the motherboard for the first time, on the back of the heatsinks you are going to have some plastic protection, so it's important that you remove it before first use. So our RAM is going to go into these 4 sockets here. So to prepare the sockets to receive the RAM, we just need to open the clips on each side of the socket. Now I am going to be installing 4 sticks of RAM. If you're only installing 2, it's important you check your motherboard manual as to which of the sockets you should install into first. It's normally the 2nd and 4th socket along from the CPU that you should use. And if we have a look at our motherboard here, there's a little diagram that tells us that it is indeed the 2nd and 4th socket along that we should use if we've only got 2 sticks of RAM. So this is our RAM, and what you'll notice is there's 2 little gold connectors on the bottom of it. Importantly, they're not of equal length. The one over the right hand side is slightly longer than the one at the left hand side. So it's really important we install the RAM in the right orientation of the socket to avoid causing any damage. So what we want to do is line the RAM up with the socket on each side, making sure it's the correct way round. Once we're happy it's in the right place, all we need to do is apply some firm pressure to the top of the RAM and it will click and lock into place. And then it's just the same process with each of the other sticks of RAM. Okay, so that's the RAM installed. Next thing to do is get the motherboard into the case. So what we're going to do is to remove the heatsink from the motherboard Okay, so our motherboard's going to go here, and what you'll notice, there's 3 rows of 3 standoffs, so 9 standoffs in total, and this is where we're going to secure our motherboard. There's a little code on the case which tells you where the standoffs are. So A is for ATX, M is for micro ATX, and I is for mini ATX. We've got an ATX motherboard, and if we notice that all the standoffs are currently in the correct location, they're all currently in the A location. So if you had a different size of motherboard, you may have to remove the standoffs and change them to one of the different socket locations. The other important thing to point out about the middle standoff is there's nowhere to screw in to the middle standoff. Some motherboards do it this way, and the middle standoff is designed to pass through the hole in the motherboard and hold the motherboard in place, making that a little bit easier for you to secure the other screws. Again, people will try and screw into this middle one and realise that it won't actually go in and can't understand why that's happening. And again, that's a fairly frequent question I get asked in the comments. The other question I get asked in the comments is, why do I install my motherboard with the case standing up? Would it not be much easier to put the case on its back and install the motherboard that way round? The answer is yes, it would, but the problem is you guys wouldn't get a good view of me doing it. So that's the reason I install the motherboards with the case the right way up. If you're doing this at home, I would recommend turning the case on the back, and you'll find the installation that little bit easier. Final thing to mention, all the screws we're going to use to secure the motherboard come in the case accessory box. So all we need to do is slide the motherboard into its right place, and then try and line up that middle socket with the middle hole. Another feature with this motherboard is actually the middle hole is in behind this M.2 SSD heatsink. So if it was one of the motherboards where you had to actually screw it in, you would need to keep this heatsink off until you'd secured the middle screw in. And also another thing to mention is this motherboard comes with the I/O shield pre-installed. If you have a separate I/O shield, make sure you put it into place in the case first before you install the motherboard. So you can actually see our motherboard's actually holding there pretty well with that middle standoff. So we're just going to get the rest of the screws in place. Okay, so that's the motherboard installed. The next thing I like to do at this stage is to install the case cables. So the case cables are the cables coming from the front I/O. So up the top we've got 2 USB type A connectors, and we need to install this USB 3.0 cable in the motherboard for them to work. There's type C connector, and this is our type C cable which we need to plug in to the motherboard. There's a headphone and microphone jack, and we need to plug in the HD audio cable for those to work. Also, our front panel has a power switch, a reset switch, and an LED which lights up when there's power. So we need to plug these tricky front panel connectors in as well for all that to work. The reason I like to do it at this stage is when you start adding more things into the build, it gets much more difficult to access the ports on the motherboard. So it's a good time to get things plugged in now while there's less in the case. Okay, so the first cable I'm going to plug in is our HD audio cable. And in most motherboards you find it's the port down the bottom left hand side of the motherboard where that goes, and that's exactly where it is in this particular motherboard as well. So the best thing to do is to bring the cable down through the nearest cutout to the port that you're going to plug it into. So we can see we've got a little cutout down here, so I'm just going to feed the cable through here. So it's important we install this cable the right way round. If you look at the header here, you'll notice in the top row there's a pin missing. So it's only going to plug in one way round. And if we bring our cable through, what you'll notice, it's the text up is the way we're going to need to install it. So we just line things up with the socket. And once everything's lined up, it's just a little bit of pressure. Shouldn't be very much. And it's just going to clip into place. And then we're going to push the excess cables out the back of the case. Okay, so the next lot of cables to install are our power switch, reset switch, and power LED. And it's going to go into this header just here. So I'm going to bring the cables through here. Now these are the most tricky cables to plug in any build because all the individual cables need to go into certain pins on this header. So you're going to need to look in your motherboard for the diagram. So it's important we pay attention to which of the sockets on the cables are positive and which are negative. So the power LED, it tells you on it, there's a positive and there's a negative. If we look at the power and reset switches, there's no positive and negative on the side with the text. But if we turn the cable over and you look closely at the back of the cables, you'll notice there's a little arrow. So the arrow marks the positive pin. Okay, so starting off with the bottom left hand pin, it is for power LED positive, so we'll go ahead and plug it in. And the one directly above it is for power LED negative. Directly above that is the power switch, and it goes positive and negative from bottom to top. So we've got the power switch cable with the text facing towards the right hand side, and we'll plug it in. The reset switch goes to the pins directly beside that, but it's the opposite way round, with negative at the bottom and then positive at the top. So I'm going to have the text facing to the left hand side this time, and then we'll plug it in. Okay, and then all we need to do is pull any excess cable out the back. So our two USB headers are down the bottom of the motherboard. So our USB Type-C is here and our USB 3.0 header is here. So we'll make a start of plugging these in, starting off with the Type-C header. So I'm just going to bring it up through the closest cutout, line things up with the socket, and then just push into place and tuck any excess cable out the back. Okay, so bringing our USB 3.0 cable through. Be really careful plugging this one in. Out of all the pins in the motherboard, I think these are probably the easiest to damage, and if you damage these, the front ports on your case aren't obviously going to work. There's a little notch in the top of the cable, just here, and there's a little notch in the top of the header, so just make sure things are lined up the right way round. And again, if there's any difficulty pushing it in, stop, don't apply excessive pressure. So that's things lined up. Just a little bit of gentle pressure and it locks and clicks into place, and then I'm going to tuck any excess cable out the back. So that's all the case cables coming from the front I/O panel plugged in, but this case does technically have one more case cable, and it comes from the included fan hub. So at the top of the case here, there's a fan hub. We've got two wires coming from it. One is a SATA port, which we're going to need to plug into our power supply to power the hub. If we don't plug this in, the fan hub won't work. The other cable is a PWM connector cable, which we're going to need to plug into one of our system fan headers on the motherboard to allow the fan hub to connect with our motherboard. So we'll go ahead and plug that into one of the system fan headers now. So our motherboard has 5 system fan headers, so we could technically plug into any of them. I'm just going to go for system fan header 1 because it's going to be easier to remember when I go into the BIOS to set up the fans. You'll notice the plug coming from the fan hub has 4 pins. There's little notches on the back of it, so it's only possible to plug it into the socket in one particular way. And that's important because each of the pins needs to go into the right connector on the header. So these little notches, make sure you only plug it in the right way round. So we're going to line things up and then just push the connector into the header. And that's the fan hub now connected up. Okay, so the next thing I'm going to do is install the power supply. The reason I like to get the power cables plugged in at this stage as well is exactly the same reason as the case cables. As you can imagine, we've got connectors up here. If we were to install our AIO at the top, it can be quite difficult to plug these additional power supply cables for the CPU into place. In general, the 24-pin cable is not going to get obstructed. There's also going to be cables coming to the graphics card as well when we go ahead and install it. So let's go ahead and get the power supply installed. Okay, so this is our power supply. As I mentioned in the introduction, this is a fully modular power supply, which means none of the cables are plugged in. The big advantage to this is we only need to plug in the cables that we're going to use for this build. There's non-modular power supplies come with all the cables already included. So if you're not going to use them, they're still stuck in the power supply, taking up space in the bottom of the case and certainly make cable management much more difficult. Downside to this is the fully modular power supplies tend to be a little bit more expensive, and then we've got semi-modular power supplies in the middle where some of the cables are plugged in and some of them are optional. So we're going to need to go ahead and plug in the cables that we're going to need. Okay, so we'll start off with our 24-pin connector, and it's going to go into these two sockets here. So we'll just line things up. Next, we're going to need to plug in a PCI cable for our graphics card. So this one cable has two 8-pin connectors on the end, which is what our graphics card is going to take. So we're only going to need one cable for the graphics card. So I'm going to plug it in down here. So we're going to need two cables for additional power to the CPU. So that's the two 8-pin sockets at the top left-hand side of the motherboard. You notice these cables are marked CPU on one side and type 4 on the other. So the type 4 end is going to plug into the power supply. So again, just going to work along the bottom here and plug these in. Final cable for us to plug in is a SATA power cable. Although we're not installing any SATA drives in this build, the fan hub in our case and also our AIO is going to need a SATA connector. So we're going to need to go ahead and install this. This single cable has 3 different connectors for SATA power, so each of those is going to provide an equal amount of power and should be sufficient for our build, just plugging the one cable in. So I'm going to plug it into the first SATA cable, which is just down here. Okay, so that's all the cables installed into the power supply that we're going to need. I did mention at the start that I'm going to use some custom cable extensions. Now these are purely aesthetic, they don't offer any functional benefit, but I think they do make the build look much better. The downside is that they're going to be more expensive, and as well you're going to have longer cables, so they could be that wee bit more difficult to manage at the end of the build. So we'll go ahead and plug these in, but again, if you don't want to install these, your power supply is ready to install. And anywhere I plug one of these extensions in, you would just plug the same cable straight into the motherboard. So starting off with our 24-pin cable, which is here. So all I'm going to do is line the notches up with a notch on the extension and plug it in. Okay, next thing, it's the PCIe cables for the graphics card. So you'll find the graphics card cable split into a 6 and a 2 quite often to make an 8-pin, because some graphics cards will require a 6-pin cable as well as an 8-pin. Ours takes 2 8s, so we're going to plug all them in to the extension. Okay, and same thing again with the other cable. Finally, we've got our 2 CPU cables. So line the notches up. Okay, so you can see our cable extensions are going to add a significant amount of extra cable to the back of the case. So if you have a small case, they can make cable management much more difficult. Final thing for us to do is install the little bracket onto the back of the power supply, allowing us to install this in our case. Okay, so all we need to do is line the little bracket up with the holes on the back of the power supply. There we go there. And the screws to secure it are going to come in the case accessory box. Okay, so we now can put the power supply into the case. I'm just pulling all the cables through. And before we insert the power supply, it's important we insert it with the fan facing down the way. So fan facing down, I'm just going to slide this into the case. And then all we need to do to secure it is screw up the little thumb screws on the back of the bracket. There we go, and that's the power supply in place. Next thing to do is to plug the power cables in. So I'm going to start off with the additional power for the CPU, so I'm going to bring it through this cutout. And then importantly, line the notch up on the cable with the notch on the socket and just push it in place. Just a quick correction here. Once you actually put the radiator at the top, you can't see the cable extensions for the CPU. So rather than do what I'm showing you in the video, I would recommend you leave the custom cable extensions out for the additional power connectors to the CPU and just use the cables coming from the power supply itself. The other cable extensions to the 24-pin connector and the graphics card are fine. but you'll just have more difficulty with cable management using these extensions and getting no benefit from them. Next, I'm going to bring our 24-pin cable through this little cutout here. I'm going to line the notches up with the socket and then push, and it locks and clicks into place. This again has cable combs, 3 of them this time, so we're just going to tidy the cable up with the little cable combs. There we go. And then I'm just going to bring the 2 cables for the graphics card through this bottom cutout. So they're going to be ready and waiting for us when we come to install the graphics card. Okay, so the next thing for us to install is the case fans. And as you'll notice, this case comes with 3 140mm case fans pre-installed. So we've got 2 on the front and 1 at the back. I want to spend a couple of minutes talking about fans and explain a few important points about them. So fans tend to have a front and a back. You can tell this is the front, it's got the logo on it, there's nothing obstructing the fan blades. On the back you tend to have these little plastic bits obstructing the fan blades. So importantly, air moves from the front of the fan out the back. So it's really important you install the fans the right way round so they move air through the case in a direction that you want it to go. So in general, we want air to come in through the front of our case, at the bottom of the case, and out the back and out the top. And that's just a general way that most cases will tend to work. So you'll notice the fans at the front of the case are installed with the front of the fans facing the front. This is the back of a fan, so air is going to come in the front. This fan at the back has the front of it inside the case and the back facing the rear, so it's going to blow hot air out of the case. So the fans at the front we would call intake fans, the fans at the rear we would call exhaust. The fans at the front are intaking cool air, the fans at the back are exhausting hot air. So because we're going to put a 360mm radiator at the top of this case, we have 3 additional case fan locations that we can occupy. There's one at the front just below the other 2 pre-installed fans, and there's 2 down the bottom of the case. So if we're going to put one at the front, it would make sense that it's an intake, and the 2 at the bottom would also be intakes as well. Now it is important that you look at the number of intakes and exhausts that you have, and people have all sorts of different arguments as to whether positive or negative pressure in a case is better. In general, I prefer the case fans to either be balanced or have positive pressure. And by positive pressure, what I mean is more intake than exhaust. The reason I don't want more exhaust than intake is that would create negative pressure in the case, and that would result in air being drawn through non-vented surfaces, such as these brackets at the back, and that is going to bring dust. So we want all our air to come in through the filtered places of the case. So in general, I prefer positive pressure or balanced fans. The other important thing you need to factor in when you're doing these calculations is that just because you have the same fan in intake and exhaust does not mean that it's necessarily going to be balanced. Intake fans generally have a filter, and that's going to create a bit of resistance and limit their airflow. Exhaust fans, as we have in the back here, don't have a filter. That doesn't make sense to filter an exhaust. All that's going to do is limit its function. So if we had the same fan on the front going up against a filter and a fan on the back that's unobstructed, you're going to actually have negative pressure in that case because the front fan is going to be limited, the back fan isn't. So that's something we're going to need to factor in. Having a radiator between the fans will actually limit airflow even further. Okay, so looking at what we're currently going with to help us decide about whether we should or shouldn't put any more case fans into this case. So at the moment we've got 2 140mm fans as intake, 1 140mm as exhaust, and then 3 120mm fans on the top as exhaust. So factoring all that in, the 3 120mm fans are probably going to shift more air. Well, they almost certainly are going to shift more air than one of the fans at the front. So at the moment, I would say our case would have negative pressure if we left it without adding any extra fans. So I think it makes sense to add one extra fan at the front as an intake below the other two fans that we have installed. The other place that we can install fans is down the bottom of the case. So if we take one of the fans and put it down here, and I think you'll already see what the problem is with this. We can have two of these 140mm fans down here as intake, but the problem is we're going to have a lot of cables down the bottom of the case, and the problem is it'd be very easy for these cables to go into these intake fans. What we could do is have the fan very far over to this side, but the problem with that is it's actually a solid panel all the way over to here. So the only place where an intake fan is going to provide any benefit is where all these cables are going to be. So again, it doesn't make sense for me to have these two intake fans down here. When I come on to do the thermal testing, I will add them in to the build to test their effect. But for now, I'm just going to add one additional 140mm fan to the front as an intake. So because the fans I have got are different to the ones that come with the case, I'm going to move the back fan to the front and then install my additional fan in at the back. And I think that's just to keep everything looking symmetrical. So to remove the back fan, all we need to do is loosen the 4 screws at the back. And we should just be able to pull it out. And then I'm going to go ahead and install the Be Quiet fan, which I got. Just going to slide the cable first of all out the back. Slide the fan into place. Then I'm just going to secure it at the back with the 4 screws which came with the fan. Okay, so at the front we just slide the fan we removed from the rear in below the other 2 fans. And then we can secure it in place with the 4 screws that we removed with the fan at the back. Now it's important when you're tightening fans up that you don't want to over tighten them. That's one of the commonest causes of fan noise, so it really only just needs to be tight enough to hold it in place without overdoing it. Okay, so we're now ready to go ahead and plug our fans into the fan hub. But before we do that, I want to explain a little bit about 3-pin and 4-pin fans. So 3-pin fans don't have a PWM connector. That's the pin that's missing. So you need to run them via voltage DC mode in the motherboard BIOS. 4-pin fans have the additional wire and they can work via PWM. So this fan hub has 2 different connectors. It has 6 3-pin connectors for 3-pin fans and 3 4-pin connectors for 4-pin PWM fans. Now what's important is we can plug a 4-pin fan into here. There's little notches on the connectors and little notches on the headers, so you can only plug them in one way round. What's important is you would need to go into the motherboard BIOS, and even though the fan is designed that it can be run in PWM mode, as long as you run it in DC mode and set the voltages to control the fan speeds, it will work just the same as a 3-pin fan. Likewise, you can go ahead and plug a 3-pin fan into one of the 4-pin connectors, and again, because there's little notches on the cables coming from the fans, it's only possible to plug them into 3 of these pins, the right 3 pins. You can't plug them in the wrong way round. There is one very important additional step you will need to take with this fan. You will need to go into the motherboard BIOS and make sure that the header is set to run in DC mode. If you plug a 3-pin fan into a 4-pin header and it's currently running in PWM mode, the fan will run at 100% all the time. Okay, so how does this apply to this particular case? So the fans that come with the case are 3-pin fans, so it makes sense for us to plug it in to this side. The additional Pure Wings fan that I got is a PWM fan, so I'm going to plug it in to this side. And again, we'll set the fans up later at the end of the video. Okay, so I've got the 3 cables coming from the 3 included case fans at the front, so I'm just going to line them up with the header here and push them into place. Okay, so I've got the cable coming from the Be Quiet fan. It's got 4 pins on it. I can still plug it in over this side if I wanted to and run it in DC mode. So I'll show you how that works. And because of the little notches on the connector, it can only go in one way. But to keep things right, I'm just going to plug it in over this side into one of the 4-pin connectors. Okay, final thing for us to plug in, coming from our fan hub, we've got a SATA power connector, so I'm just going to plug it into one of the SATA connectors coming from our power supply. So it's important we just line the L's up on the connector so they're round the right way and just push it into place. So that's all our case fans connected up. Okay, so now we're finished with the fans at the bottom of the case. I'm going to go and put this little bracket back on again. So it's a matter of lining things up and pushing it down into place. As you can see, because we've installed an additional fan down here, this bracket will no longer fit. And it's a nice thing Fractal have done with this case. Some other ones, they have a large cutout and you either have to have it on or off. So having it split into sections is a nice idea. Okay, so the next thing for us to install is our I/O. Really what we have is a pump, some tubes and a radiator. The pump has a cold plate on it, and this is up against the CPU with some thermal paste between the two of them. So as the CPU makes heat, the water coming past it helps cool the CPU. The hot water then goes back to the radiator. We're going to have fans on the radiator blowing cool air through the radiator, hopefully cooling the water. And then we've got cooler water coming back to the CPU, and that cycle continues. So the first thing for us to do is to put our fans onto the radiator, and it's important we put the fans at the right orientation. So I've already had a look at the case, and I think the tubes over to the right hand side are going to look better than the tubes to the left hand side. We're going to want to put our radiator up at the top of the case and the fans on the inside. You can do it either way, but if we put the fans at the top, we're not going to see the RGB from the fans, and all we're going to see is the radiator. So it's going to look much better having some light coming into the case. So it's important we have radiator and then fans. It's also important we put the fans on the radiator the right way, and we've already talked about the orientation of the fans on the case fan installation section. So this is the front of the fans. It's going to bring air in from the front and out the back. And we want to set our radiator as an exhaust at the top. So we're going to install our fans in this orientation so that they are exhausting air through the radiator. I tend to have the radiators at the top as exhaust and the radiators at the front as intake, and that just fits with the natural process of air moving through the case. In general, an intake is going to give you better CPU temperatures. The reason I've stayed away from intake in this particular case is I think it's going to look slightly better at the top. We probably would get better CPU temperatures with the radiator as an intake, and that's something I'm going to test in my thermal testing video with the case review. So it might be worth checking that out to see the benefits that you're going to get from that before deciding where you're going to install your radiator. Or if you want to copy this guide exactly, this is going to be on the top as an exhaust. The other important thing with the fans is we want the cables coming from them at the back of the case. So that's going to mean the cables are going to have to be here. So we'll go ahead and secure the fans to the radiator using the long screws that come with the I/O. Next, because our case has the detachable top bracket, we can go on ahead and fit the radiator to the bracket outside the case. So I'm just going to line it up with the middle of this bracket, and then we can secure it in place using the shorter screws that come with the I/O. So just a quick correction here, I would actually recommend installing the radiator closer to the front of the bracket. So you'll see where I'm screwing it in here on the video. There's a slot at the front of each of the rows, and I would actually move the radiator slightly further forward and use the forward slot both at the front and the back. The reason for this is you will struggle to install the radiator past the motherboard if you don't install it in the front location on this bracket. So I've just screwed this in very lightly, so there's still a lot of movement on the bracket. So what I'm going to do is I'm going to put this into the case, position the radiator where I think it looks best, probably in the center, but I've left it loose just to be sure, and then once I'm happy with it, I'll tighten each of these up to secure it in place. Okay, so before I put the IO on, I'm just going to feed the cables for each of the fans out the back, because obviously once it's on, it's going to be much more difficult to feed them. So you can see there's very little room at the top, and with the IO installed, it's actually blocking the top fan headers on the motherboard. So we are going to need to plug a couple of things into there. So I'm going to go ahead and plug them in now. So I'm just going to lift this backwards. So the first thing to plug in is there's going to be a triple fan splitter cable, which each of the fans in the radiator at the back is going to plug into. And this is going to need to go into the CPU fan header. So the CPU fan header is the header at the top of the motherboard on the left hand side. The one to the right of it is for the pump header. So I'll go ahead and plug the fan header in. I'm going to bring it in from the back. Okay, so that's plugged into place. Okay, so coming from our pump, we've got two connectors. One is for RGB, the other is a 3-pin fan connector, and that's going to power our pump. So although the header on the motherboard has got 4 pins, we've already mentioned there's no problem plugging a 3-pin header into it and making sure we run it in DC mode. I'm just going to get that plugged in, and again it's only going to go on one way on the right 3 pins because of the little notches on the cable. And I'm just going to push this one for the RGB through the back. And start to pull the excess cable coming from the pump header out the back as well. Okay, so we can now go ahead and secure the top bracket back onto the case. Okay, so I've already got the first problem. The radiator doesn't fit here because of the motherboard, so I'm going to need to move the radiator further to the right hand side. So one thing I forgot to mention earlier, I have used this CPU cooler before. Whenever you first get it out of the box, instead of this AMD bracket that's on it, there's an Intel one already on it. It's easy enough to replace. All you do is apply a little bit of pressure here and the bracket will slide out. You can then take this one, which is the AMD one, slide it back into place, and you're ready then to go ahead and install the cooler. So we can go ahead and add a little bit of thermal paste to the CPU. Normally just about a pea-sized amount in the center of the CPU is my preferred method of doing this. That looks about right. And then we can go ahead and just put the little clips from the bracket over the little clips on the motherboard at the top and then at the bottom. Okay, so that's the little clips on each side. All we need to do is tighten the 2 screws to secure the cooler. And again, we want to make sure we don't over tighten it. So generally I tighten one side, then the other side a few turns, and just repeat that process. And that way you don't put too much pressure on one side at once. Okay, so now we come on to the tricky part, and that is connecting everything up. What's important to remember, each of the fans on the radiator has 2 wires coming from it. One is a 4-pin wire which needs power, and the other is an RGB connector. The pump header has already been powered. It's plugged into the pump header on the motherboard. So to get power to the fans, we've already plugged in a triple splitter cable to the CPU fan header. So all we need to do is plug each of the 4-pin connectors from the fans into that splitter cable. So we'll go ahead and do that now. Okay, so that should be the power side of things taken care of. The fans are going to get their power via the CPU fan header, via that triple splitter, and the pump is going to get its power via the pump header. The alternative option, if your motherboard didn't have a pump header, there's a SATA connector which that can plug into and then go to your power supply. But because we have a pump header, it makes sense to plug into that. So now we come on to the RGB. So at the moment at the back of the case, we've got 4 RGB connectors, 1 coming from each of the fans and then 1 coming from the pump itself. So the first thing we need to do is connect a triple RGB connector up to each of the ones coming from the fans. So we'll go ahead and plug that in now. Okay, so that now leaves us 2 RGB connectors. There's a 3-pin connector coming from the pump and a 4-pin connector which is coming from that triple splitter cable from each of the fans. We've now got 2 options of how we can control the RGB in this case. We can use the controller that Lian Li supplies, or we can connect these into a cable and run it into the ARGB header on our motherboard. So because our motherboard doesn't actually have any RGB on it, I'm going to go ahead and use the controller. It's going to save us having to install the motherboard RGB software and make things a little bit simpler. Okay, so this is our controller. It has 2 connectors, one for a 3-pin, one for a 4-pin. So it makes sense that we go ahead and plug these into the corresponding pins. So the 3-pin one is going to go to the pump head. And then the 4-pin one is going to go to that triple RGB splitter cable. We're going to have buttons on this controller which is going to let us adjust the RGB. So the only additional thing for us to do is to power this controller. And that's a SATA connector. So we're going to plug it into the SATA cable that we used earlier on. Just line up the L's. And there we go. That's our AIO installed. Okay, so next thing for us to do is install our graphics card, and it's going to go into the top PCIe slot on our motherboard. Although the other slots could accommodate a graphics card, the reason we don't want to install it here is the top one is going to give us the fastest speeds. The other thing to look at in this case is there is an option to install the graphics card in a vertical orientation. Main reason for doing this is aesthetics. It tends to look better depending on the graphics card in a vertical orientation, and in certain cases the cooling can also be better in that orientation as well. My main concern about doing that using these brackets at the front of the case is the graphics card fans are going to be right up against the tempered glass panel. I have tested this previously, and having the graphics cards in one of these front mounted sockets resulted in it overheating. And in fact, when I moved it to one of these sockets at the back, the graphics card temperature under load reduced by 19 degrees. And then based on this, I don't recommend using these graphics card vertical mounts, which are right up near the front tempered glass panel. So if you were going to want to install it vertically, I would recommend using the kit and it's converting the standard horizontal PCIe slots into a vertical slot and installing it further back in the case. We're just going to install the graphics card in a horizontal orientation today. So to do that, we're going to need to remove the second and third bracket from the top. Next, we just need to open the clip by pushing it backwards. And then it's just a matter of lining the graphics card up with the slot and then pushing it into place. And we should hear a click as it locks into place. There we go, that's the click. And then we just need to secure it in place using the little thumb screws that we removed earlier on. Then we just need to go ahead and plug in the cable extensions, which we pushed through the case earlier on. Okay, so we just need to line the notches up. And the same again for this one. And then it's just a matter of tidying up the cables with the little cable combs. And then pulling the excess cable out the back. Okay, so before we move on to the cable management, I just wanted to let you know about two small changes I've made during the build. I've removed the black and white cable extensions going to the additional power for the CPU over to the top left hand side of the motherboard. And the reason for that is you can't actually see them past the radiator. So there's no point having them there. They're going to make more difficulty with cable management at the back of the case. The other change I've made is where I've secured the radiator to this top mounted bracket. So previously I had the screws going in here and here further back, and I couldn't actually get the radiator fitted where I wanted because of the motherboard. So I've actually moved it forward a row, and then I have no difficulty at all centering the radiator where I wanted in the case. I had preferred it slightly to the left, and I was having to actually install it all the way to the right because it wouldn't fit past the motherboard. So when you're installing it, make sure you install it in the front of this bracket. So now this brings us on to my least favourite part of any build, and that is cable management. So we have to sort out this mess of wires so we're able to get the rear panel on. So hopefully this case will be a bit easier than usual because we've got lots of Velcro straps for our cable management here. There's also other little points where we can use the cable ties which came in the accessory box to help tidy things up. And again, because we've removed the hard drive cage and not installed any bottom fans, there's plenty of space at the bottom of the case for excess cables as well. So we'll get on with that. Okay, so it's time to put the rest of the panels on. Important to mention, because the front is going to be an intake, I am going to leave the dust filter on for now. Up top it's going to be an exhaust, so there's no reason to have a dust filter plus a mesh, so I'm going to remove the dust filter from there. I am planning to do a lot of thermal testing. That's going to be included in the case review, so you might want to look at that before deciding about the dust filters in the case. So that's the build complete. I think it looks great, but does it work? So we've now come to the moment of truth where we need to flip the power switch and see what happens. Importantly, I do have a Windows 10 bootable USB drive in the back of the PC. If you don't know how to make one, I've made a video on it, so I'll put a link to that video in the description. So the moment of truth, let's see what happens. Okay, so a good signs, we've got lights, we've got fans spinning. So we just need to have a look at the screen and see what happens. The first thing we're looking for is the MSI logo to appear, which is great. We've got that first bit. Next thing we're looking for is the PC to find the USB bootable drive and try and boot off that. So I'll be looking for the Windows logo to start to appear to show that it's found the bootable USB drive. It can just take a minute or two for this to happen, so we'll just wait patiently So that's a good sign. We've got that spinning wheel, so it looks like it's finding it. And there we go, we've got the Windows installer screen. So I'm going to now run you through how to install Windows. To make it a little bit easier, I'm going to switch over to the screen mode. Okay, so we're in the United Kingdom, so I'm just going to go ahead and click Next. And I'm going to click on Install Now. So if you've got a Windows 10 product key, you can go ahead and enter it in the box. I'm often asked the question, if you don't have one, what should you do? So today I'm not going to enter my product key. I'm going to click I don't have a product key and show this to you. So what you need to do is select which version of Windows you're going to get a product key for in the future. So I'm going to click on Windows 10 Pro and click on Next. So you just need to accept the license terms, click Next. And then we're going to want to do a custom install. So here you can see we've installed two M.2 SSDs and we've got two drives showing up, drive 0 and drive 1. So a question I often get asked, if you have two 1 terabyte drives like we do, and we want to install Windows on a particular drive, say we want to install it in the Gen 4 SSD, how do I know which is which? And I don't have a great way of doing this. Maybe people watching will actually have a better way of doing this, and if you do, share it in the comments. What I tend to do is if I have two drives of the same amount, I will disconnect one of them briefly while I install Windows on the one I want to install it on, and then I'll add the extra drive in at a later stage. Now if it's a SATA SSD, that's an easy process. You just unplug the SATA cable briefly while you're doing the installation. An M.2 SSD, I just won't install it until a later stage. I'm not planning on keeping this build after I install it, and I don't particularly mind which is which, so I'm just going to go ahead and select drive 0 for the purposes of this today and click Next. And then this is just going to take a little while Windows starts installing, so I'll speed this up for you. Okay, so we're in the United Kingdom. I'm just going to click on Yes. United Kingdom layout for the keyboard as well, and I'm going to click Skip to a secondary keyboard. So I'm going to set this up for personal use, click Next. So here you can create Windows with your Microsoft account. If you don't have one, you can create an online account. The alternative is to do this offline, and again, people ask me, do you need to be connected to the internet to install Windows? And no, you don't. So I'll show you this option as well, because I haven't done this before, and click Offline Account. I'm going to click on Limited Experience, and then it's asking me to use my name, so I'll type my name in, click on Next, make a password, click on Next, and then it's going to ask me some security questions. It's asking us about online speech recognition. We'll go ahead and click Yes for this. Yes to find my device. We'll send basic diagnostic data. No to inking. We're going to click No to this. No again. And then we're going to click No to device activity history. Going to click on Not Now. Again, obviously, if you guys have different options that you prefer, go ahead and click them. Okay, so that's Windows fully installed, and I know it's really tempting to go and start looking for drivers and other programs that we're going to need, but what I think you're best doing is getting Windows fully up to date before we do anything else. So let's go ahead and update Windows. So to do that, we click on the Windows icon down the bottom left-hand corner, click on the Settings tab, and then what we want to do is go to Updates and Security. We're going to click on the Check for Updates button. Windows is going to go ahead and find a number of updates. It may need to restart a number of times during this process, and then when we restart it, it'll find more updates. We're going to keep doing this until there's no more updates available. Okay, so that's Windows fully up to date. There's no more updates available. So the next thing I like to do is to get all the SSDs to show up. because although we've got two M.2 SSDs, I'll put money only one of them is showing up when we go and look at it in my computer. Okay, so we go ahead and click on the File Explorer icon down the bottom, click over here and click on this PC. What we can see is there's only one drive, local disk C, appearing. We do have two M.2 SSDs, but we're going to need to get the second one to show up. So what we do down the bottom here, if we type disk management, this shortcut's going to come up, create and format hard disk partitions. So we'll go ahead and click on that. So we're going to get a little pop-up asking us to initialize the second disk. So we're going to go ahead and do that, clicking OK. So we have a look, disk 0 has got our operating system on it, and it's been allocated drive C. We've now also got disk 1, which is unallocated space. So we right click on disk 1 and click New Simple Volume. Click on Next. We can assign it a letter. It's currently D. If we want to change it, we can do that from the pull down menu. I'm going to leave it as D and click Next. And if we want to give it a name, we can type it in here. So I'm just going to call it second M.2 SSD. Click Next and finish. Okay, so we can close this down, and if we go back to here, you'll now notice we've got two drives showing up and ready for use. Next thing for us to do is install any drivers that we're going to need to get the PC running effectively. So we're going to get these for a variety of sources, and don't worry about collecting the links as I go along. I'm going to include all these links in the description. Okay, so we're over on our motherboards page on MSI's website, so we go ahead and click on the drivers. Select our operating system, which is Windows 10 64-bit, and then we've got a whole collection of drivers that we can install here. So I'll expand them so you can see what we've got on offer. Okay, so we've got onboard set of drivers. So we've got AM4 RAID driver. I'm not going to use RAID in this PC, so I don't need to install that. We've got the AMD chipset driver. This is something that I will install, but I'm going to get it from AMD's website because they tend to have a more later version over there than what we're going to get from MSI. Onboard VGA drivers, we've got a dedicated NVIDIA graphics card, so we're not going to need this, so I'm not going to go ahead and install it. Okay, so we've got some LAN drivers. We've got a Bluetooth driver, so let's go ahead and download this. Okay, we're going to click on Open File, click on the Bluetooth driver, and we're going to click on Wireless Setup, click Extract All, click Extract, and then we're going to click on Wireless Setup. Click Yes, Next, Next, accept the terms, click on Next. We're just going to go for a typical install and click Install. And then click Finish. Okay, next one along, we'll install the Intel Wi-Fi driver. Again, Windows will have found a lot of these drivers or equivalent drivers already, so these ones are optional. Click on Open File. And we've got the wireless setup application. We'll click on that again. Click Extract All. Click Extract. Going to click on Next. Click Agree and click install. Yes. Click finish. And then we'll click over here and download. Click open. Click on the setup. Click yes. Next. Install. And click finish. Okay, so that's all the LAN drivers installed. We can go ahead and install the onboard audio drivers. So we're going to go ahead and click download. Click open file. There's the setup. Click on it. Click yes. Next. And we'll go ahead and restart our computer now and click finish. Okay, so that's all the drivers installed that we're going to get from MSI. We are going to need the chipset driver, which we're going to get from AMD's website, and we're also going to need drivers for our graphics card, which we'll get over from NVIDIA's website. Before we leave MSI, there's a few other bits here that are worth taking a look at over in the utilities section. So if your motherboard did have RGB on it, or you had plugged something into the RGB headers on your motherboard, you're going to need to install the Dragon Center to let you control that RGB. As we've used a controller for AIO, we don't actually need to install this software at all. The BIOS is the other thing that is worth updating, certainly with new CPUs coming. In general, I don't recommend updating the BIOS unless there's new functions that you want to use, or else you're having trouble with your computer. So this is the latest version of the BIOS. It was only updated 3 days ago, so I'm going to go ahead and update this when we head over to the BIOS. So I'm going to go ahead and download the file now. I plugged an external drive into the computer, so I'm going to copy that file from the downloads to the external drive. And we'll use this later when we go to the BIOS. Okay, so we're now over on AMD's website. We're going to go ahead and click on chipsets. We've got AMD socket AM4, click on that, and we have got X570, so we're going to click on submit. We're going to expand here, and there is the chipset driver, so we're going to go ahead and click download. And click on open file. Click yes. And then we're going to click install. then we're going to have to click restart. Okay, so we need to install the drivers now for our graphics card. So we're over on NVIDIA's website. We can either install the drivers separately or go ahead and get the GeForce Experience. I prefer to get the GeForce Experience, so that's what I'm going to show you how to do. So I'm going to click download now. And we'll click on open file. Click yes. We're going to agree and install. So we're going to need to log in. If we don't have a login, we can go ahead and create one. Okay, so I'm going to skip the tour. And we click on drivers. So up the top here, if we click on these three little dots, you can choose your preference for drivers. You can pick game ready drivers or studio drivers. And again, a question I'm often asked is, can't you install both? The answer is no. The studio drivers are going to work for gaming, but they'll be more optimized for content creation. And the gaming drivers will also work for content creation, but they'll work better for gaming. So you just have to pick your preference of the two. I use my computer mostly for content creation, so I'm going to click on the studio drivers and click download. Okay, I'm going to click on Express Installation, click yes. Okay, I'm going to click close. So although that's all the drivers that we're going to need to install, we may want to control some of the RGB elements in our build. So we can control the RAM with this software here. So I'm going to click on the download, and again the link to this is going to be in the description. We're going to open the file, click yes, click next, next, install. And we're going to have to restart our computer, so we'll click finish. Okay, so we're going to use this software to adjust the color of our RAM, and we have a whole variety of effects here that we can turn on. So I can click on rainbow, click apply. But I much prefer to keep the RAM just a static white, so I'm going to click on static, click on LED 1, I'm going to drag all the colors up to the top and click apply. So that's just changed the first LED, but what we can do is sync all LEDs to LED 1 and then click apply. And we've now turned the RAM white. Our graphics card also has RGB on it, so we need to get the software to control it from ASUS's website. So again, you'll find this link in the description. This one's quite hard to find, so we're going to click on Software and Utility and See All Downloads and work our way down the list. And this is what we're looking for, Aura RGB lighting control for a graphics card. So we're going to go ahead and click Download. We're going to click on Open File, click Extract All, click Extract, click Yes, Next, Install. And we're going to have to restart our computer, so we'll do that now and click Finish. Click Yes. Okay, so this is the software to control the lighting on the graphics card. So we can pick whatever color or effect we want. So let's click on Color Cycle to see what that looks like and click Apply. And again, I just prefer to leave the graphics card a static white. So I'm going to click Apply again and leave it on white. It's actually a slight off white, but we don't seem able to get a full white color on the graphics card. Okay, so that's all the drivers and RGB software that we need to control our build, and I think it looks much better set to white. So the next thing that I want to do is head over to the BIOS. Firstly, we're going to update the BIOS, and then we're going to adjust a few settings in the BIOS. Again, I don't recommend you routinely update the BIOS, because if you do it incorrectly, you can brick your motherboard. It's really important that you don't shut your computer down or lose power during the update. Again, there is new features available, certainly when the new CPUs are coming. So I am going to go ahead and update the BIOS and show you how to do that. So the first thing we need to do is enter the BIOS. So to do that, we need to restart our computer. And as the computer is restarting, just as the MSI logo appears, we need to press the delete key. There's no harm in pressing the delete key early, so I normally keep pressing delete, and then when the logo appears, you're not going to miss it. So we'll go ahead and restart now. Okay, so I'm going to start pressing the delete key now. Okay, so that's us into the BIOS. Okay, so the first thing I want to do is go ahead and update the BIOS. So to do that, we're going to need to use the M.2 utility, so we'll click on it, and we're going to click on Yes. So I'm just going to plug in the USB drive and click Retry. So on the drive we can see the file here, so I'm going to go ahead and click on it. And it's asking, are we sure we want to select this file? I'm going to click Yes. And then the BIOS is going to update. As I mentioned, really important that the computer does not lose power or shut down during this process, or there's a good chance you'll brick your motherboard. Okay, so I've loaded back into Windows. I'm just going to go ahead and restart the computer to enter the BIOS again. Okay, so we can see from the BIOS build version that it's been updated to the latest version from the 14th of November. So there's a few things I like to adjust in the BIOS of any new build, and the first is the memory. So we've got memory that can run at 3600 megahertz, but at the moment it's currently running at 2133 megahertz. You can see there's two XMP profiles. They're actually both the same, and it'll run at 3600 megahertz. So I'm going to go ahead and select XMP profile by turning it on here. So we're currently running profile 1, which will push our RAM up to 3600 megahertz. Next thing I like to do is turn off the indicator LED control. I don't like the little red light and postcode at the bottom of the motherboard. I think this is distracting and takes away from the look of the build. Of course, if I'm having any problems with it booting, I can always turn this back on again. So I'm going to go ahead and turn this off as well. Next thing I want to do is have a look at the fans. And I'm just going to click on the settings. Okay, so first of all, looking at our CPU fan. So this is the CPU. It's currently running on PWM on smart fan mode. So this is the way I would tend to leave it. We have got 4-pin fans, so I would tend to run them in PWM mode, and I do use normally the smart fan mode here as well. So our pump is currently running in PWM, although our pump only has a 3-pin connector, so it's important we turn it over to DC mode. And if we want as well, we can turn on the smart fan mode, so I'm going to go ahead and do that as well. Okay, so going on to look at system fan 1, and this is the only system fan that has anything plugged into it. And this is where we've plugged the cable coming from our fan hub, which comes with the case. It's currently running in DC mode, and smart fan mode isn't enabled. So I'm going to turn on smart fan mode as the first thing I'm going to do. I'm just looking at the fans and they are all running at 930 revs per minute, which is basically full speed, despite the fact that our system temperature is only 35 degrees, CPU is only 33 degrees. The other thing to look at is taking the temperature source off the CPU, which is fine. So our fans only run at around about 1000 revs per minute, so it actually looks at the moment if our fans are running currently at full speed. So I haven't used this particular fan hub before, although it comes with a 4-pin connector, so I'm assuming it's a PWM fan hub. I'm just going to switch this over to PWM and see what happens with the fan speeds. So you can see the fan speed is falling after doing that to round about 600 revs per minute, and that's resulted in significantly less noise coming from the build. So this fan hub must run in PWM mode, and it seems whenever you select DC mode it runs at full speed. So this is a really important step if you're going to use this fan hub. Otherwise all your fans are going to run at full speed. Final thing to have a look at is our chipset fan. It's currently running in PWM mode, running off the chipset temperature, and it's working in balance mode at the moment. Okay, so I'm happy with the way all the fans are now set up. So I'm going to click the X button to close. So to save all our changes, all we need to do is press the X button in the top right hand corner. It's going to give us a summary of what we have done. So pump fan 1 has changed to smart fan mode, that's been enabled. Pump fan 1 has changed from PWM to DC mode. System fan 1 has been enabled smart fan mode and switched to PWM mode. We've also disabled the LED lights and initiated XMP profile A. So I'm going to click yes to save these. I'm going to boot into Windows to check that our RAM is currently running at the correct speed. So to check our RAM speed, all we need to do is right click on the Windows icon and click on Task Manager. We're going to click on More Details. We're going to go to the Performance tab and click on the memory. So we can now see the speed of our RAM is 3600 megahertz. So that is exactly what it should be. Okay, so that's the PC up and running just the way I would want it to be. Now, I don't normally run a lot of benchmarks when I build these PCs. I do a lot of thermal testing and tend to do that in a separate video. But because I have installed the new Samsung Gen 4 SSD, I'm going to go and benchmark the speed of it compared to the previous version of the Samsung's Gen 3 SSD. So let's go and do that now. So I'm going to go ahead and download Crystal Disk Mark from Windows. Okay, so let's have a look at Crystal Disk Mark. So we can test two of our drives. We've got drive C and drive D. I'm going to click on drive C and I'm going to click on all. So we'll let the benchmark run. Okay, so some very impressive results. So I think we can very safely say that drive C must be the Gen 4 SSD. Let's just compare that to drive D, which must be our Gen 3 SSD, and we'll rerun the tests. Okay, so that's some really impressive results, particularly with the Gen 4 drive. The first set of results were actually over double as fast as the Gen 3 drive. So I haven't really used a lot of Gen 4 drives because there hasn't been such a significant improvement, and this new one from Samsung seems to be head and shoulders above the rest of them, so I can thoroughly recommend it. And certainly if you are buying a new SSD now, it makes sense to buy the Samsung drive if you can get your hands on it. Okay, so that's the build complete. I think it's looking great and also seems to be running great as well. So hopefully you found this guide useful. If you have, I'm going to ask you to do me a favour, hit that thumbs up button because that really helps others find the video. The other thing that would be helpful as well, if you're not currently subscribed to the channel, please hit the subscribe button. The channel is growing really well, but your subscription can really help it grow further and help my content to reach more viewers. If you've enjoyed this, I've made plenty of other PC build guides and PC related content on the channel. So go ahead and check that out. As I've mentioned, I'm planning to do some thermal testing and give my review of this case after I've used it for a little while. So that video will follow on shortly. Keep an eye out for that. So I think that's everything for now. I'll see you in the next video, and thanks for watching.